He joins me today for this presentation. We are both working at the Department for Biosystems Engineering, which is located in Basel. But today we're really not talking about this, what our everyday research job, but we are talking about our ideas, how we could, using blockchain technology, change the way that we are conducting research. And so the title is Collaborative Research, and we basically will give you an introduction into our ideas. And right after, we have also Mihai, who is from the Ethereum Foundation, or one of the founders, and he actually has a much more advanced already application of what we are introducing today. And so we are really excited to have this back-to-back, and we'll see how this goes. All right, so I also want to mention that we have been part of this Future Hack. So Gotthold and me and another team member from Ireland, we have been taking part in this hackathon that happened in Davos. So we more or less know the atmosphere that you're gonna have here in the next 2 days. There were much fewer participants. And again, our project that you can also find on GitHub under this keyword here, dealt with the idea that we want to present a new paradigm of how research can be conducted. And we have also pitched this with the idea that at the core of the sustainability goals lies the solid foundation of knowledge that communities and people worldwide have access to. And that's what we believe is very important to tackle. Also, there's an article that I just want to announce if you guys want to read more about the ideas that we are developing here. I just published this in a blog that's run on the Humboldt University in Berlin, which deals with the internet and society, and you can check this out and tweet it later if you want to get a reference. All right, so to start now the talk, to inspire you, so this is the model of the first IoT device that probably has been conceived in the world. And that has been done in 1945, and it's called the Memex. And that has been, the idea behind is that this is a mechanized workspace that you have at hand. And down there are magnetic tapes, and there are switches, and you have 2 screens. And what this could allow you is to basically, as Mr. Vannevar Bush wrote here, have an individual storage of all your books, records, and communications in a mechanized form. And as you're doing your research, you can the foundation of hypertext, basically, and later on the ARPANET and the internet. However, we know today is that although we have the solution at hand now, so everyone holds his laptop in his lab, or we are lying in front of all this knowledge, and we have this new way of exploring the world, there is a problem with that. And that is that basically today we are looking at more than 28,000 peer-reviewed journals. So if you're not logging into blogs and all that stuff, just these so-called scientific journals that we can consult. And there's a research output of about 2.5 million papers a year. That's numbers from this reference here from 2014. And that is growing at a pace of about 4 to 5% every year. And the doubling rate, therefore, is about every 9 years. So that's now quite funny, because already in 1945, Mr. Bush suggested that professionally the methods of how we are transmitting and reviewing results of research are generations old, and they are totally inadequate for the purpose. So although we have this, and we have a better version of this desk, it didn't really change. The way we are working in science is still publishing papers and communicating them through journals, and that hasn't changed, even now, 60 years later. And also, he says that the aggregate time spent in writing scholarly works and reading them might be as well startling. And that's, I guess, all of us agree with that. So how can we go about this? This is what we are going to explain to you. Just to give you some more background on this. So as I said already, the number of publications is growing exponentially. At the same time, we are running at a risk of losing a lot of these. So if a paper or data set published today if you look at this, you see that over time, after 20 years, more than half of this information content is basically being lost. And also, even though we can claim that there's a growing amount of information output, the question is really if that's really true, or whether this information being published here is because we are kind of trapped in a vicious cycle of this economy of publications as well, is not increasingly empty knowledge and empty information. There's another problem with the communication, that is these paywalls. We don't notice so much here at ETH, but it's really a problem when you reach out to other communities, countries that do not have the financial power to assure access to all of these scientific journals. Like, to me, one of the #1 reasons why, since a high school student, I wanted always to be affiliated with an academic institution is because I knew I can get access to these journals that otherwise are paywalled. And leaving science, for instance, is my biggest fear is that I can't access these journals anymore easily. And we had just 2 weeks ago this scenario that the #1 science funding nation in the world shuts down their government. And for this reason, suddenly, many databases haven't been accessible anymore. You also know that this is happening for the climate data, that basically links can be deleted, so data then are just being lost. And that's very concerning problems with these centralized systems, and they are centralized in different levels, at governmental level, but also at the level of publishers that are intermediaries, actually, essentially. What's more is that the reproducibility is really low. So why are biomedical scientists so interested in a new way of finding scientific truth? It is that in our daily job, we realize that the reproducibility of the studies that we are reading is really low. And it's apparently strikingly low. So for cancer, for instance, about 10% of reproducibility rates have been found. That is in Nature source. I'm not sure how alleged they are, but
this study they are citing is done from Bayer, I think.
Okay.
So
by the pharma industry.
Pharma industry tried to reproduce the data that was preclinical because they wanted to basically, produce a drug based on that one, and they had the huge problem that they couldn't reproduce like lots of it. Yeah.
And I mean that's a daily. Depending on which field you are, it's a daily business. Though also there's a feeling that we have that this is not. Really not right what we read many times, and it's very hard to find the good information. All right.
Okay. Recap time. So basically, there are lots of problems with the science as it has been done today. There are entry barriers. In a sense, like Martin told, like if he, leaves university and he has a doctorate degree, he cannot participate in science anymore. Well, that's his problem. But not only, because lots of other people that, could be able to participate in science are shut out, They can't do it because they have these paywalls. But that's just for us. I mean, there are also countries that they have the problem, or like universities, that they cannot afford just, to enter in that science market, let's say already, or, in the process of creating science. Because, it's all paywalled and the structure is just not given. So, talking about structure, it's quite antiquated. It's like a mammoth, basically, So, you have the problem that there is no data available. So what you do is you collect data, you write a paper about it, say to the world, hey, I found that one, you publish it out, and the data gets lost. It's basically, the only thing that is left is an advertisement of what you have done. It is not really of worth then, because people are, it would be way more valuable if you were able to look into the data, really see what has been done there, and then, try recreating it or building upon that, or not building upon like an advertisement of what work had been done. Then it is also highly not collaborative. You might say, okay, science, there's lots of collaborations, and there are some collaborations, of course. But if you start to be in that science world, you will notice that there are some wrong incentives, like the winner takes it all mentality. So if you are the first one to publish whatever you have found, it's good, you're well off. But the second doesn't get anything. So what you're trying to do then is you don't communicate what you're looking at. You try to do it secretly in your cellar, not telling anybody. And at the same time, it means that if there's anybody else that wants to recreate that thing, well, why wouldn't he want that actually? Because he's not getting anything from it, because the fame is already taken. He's not the first one anymore. So basically, if you summarize it, you have entry barriers, you have problems with the infrastructure and with the governance that is sitting on top of this infrastructure, basically on the incentives part. All right, now don't push any buttons there.
All right, so now we have bashed basically the current system. So to be a bit more constructive, I'd like to walk you through an example, and that definitely will have flaws, and you will get where these flaws are, and we don't have to discuss it now. But just to give you some inspiration of how such a decentralized solution architecture could look like. So the example, but just to give you a setting, could be a question that in this case I formulated here. What is, and actually we are a bit shading it out, but so what genes are causing a critical congenital heart disease? This is a disease that would occur in newborns, and we don't know really the genetic factors, but there are likely some. And it would be great to know already through some prenatal testing to find out whether an infant would suffer from that disease or not. And imagine now you are a student, or you are anyone really in the world. Right now, you couldn't even approach this problem because there's no platform. If you don't have the stamp of approval of your academic institutional email account or whatever, you are not really able to start any serious work here. Now, in our vision, there would be a decentralized a blockchain secured and backed platform. And in this example now, a student or any person would be able to submit a study into the system. That could be the idea, and ideally, because an idea is not necessarily worth that much, already a very nicely worked out theoretical framework of how someone would conduct in this experiment. Now, this would be done in a way that directly the attribution of this would be linked to the person. That is this famous time stamping, okay? But there is more beyond than only time stamping in publication and blockchain. Because at the next level now, you could have a network, a platform, where you invite peers to review this information, to edit it as well, and everyone editing it would also be basically attributable for his changes that he has made. And we could imagine that in such a setting of kind of, it's called an idea conference, a community is already now working out in a collaborative way, best practices, define the governance, how maybe certain of these steps would be funded, and maybe even bounties that could be delivered for certain tasks that need to be done in order to deliver this research project. And at this point, it would have created enough of momentum that you get talented experimental groups, also groups from maybe less a theoretical background into the game. That could be, well, the Swiss Precision Medicine Initiative that is now receiving a lot of money. And these are the universities, institutions that have the next-gen sequencers at hand, and they have the skilled manpower in the lab that can do the experiment. And now, basically, this would be a process going in both directions from a study there that has been improved and defined beforehand very nicely. Now you would have people invited to be interested in actually conducting the experiments, and they would do this relying on the fact that they are contributing to that, and they are secured and ensured that they will be also attributed and potentially rewarded for their efforts. That's completely different and not the way we do research today. In fact, today we go to conferences that usually are quite boring because we are presented with random stuff that people have done without telling us before. And when you sit there and tell the guy, listen, this is terrible, what are you doing? You wouldn't do that because it's already too late. The experiment has happened. So ideally, you have the discussion, the statistical sound models of what you want to do beforehand. That's like how a physicist would maybe do an experiment, certainly not how biomedical scientists are doing it most of the time. Now, at this stage now, that somehow a result has come out of this, and there's a consensus reached within the analyst groups and the experts that we have really found something, this is when we would argue the traditional publishing industry that we have now would come in, and they would be very happily invited to report on the findings, because if it's a really cool finding, we need someone to spread the word, and that's exactly why we like to publish in a high-impact journal right now, to get the broadest public attention. In this way, we would say they are more like journalists, they're approaching us, and now we are getting some audience as well. At the same time, you have the industry that can now compete for licensing this technology. And it could be very well that the scientists want to make sure that they're getting a good deal, they're getting a good financial reward for their work, but at the same time, also, we could have a way in the word in how much this should cost. So not that you just sell a patent to the company and then you get a ridiculously expensive therapy out of that, as it's today. Now, the good thing would be that using this audit trails on the blockchain, you can basically ideally, and that's where we have to figure out how governance-based, but you have an audit trail. That means you could distribute the funds also to all people that have contributed. And so you would have an incentive to contribute to something, even if it's a very small amount. Later, you'll be part of this, and you can be assured that you will be part of that because your identity has been locked into the system. All right, so just to sum up the blockchain part of this, so you would basically have in this decentralized system operators that create data, analyze them and interpret them, or also propose the analytics. And this would be linked using IPFS, the Interplanetary File System, which we are not introducing now, but I guess you have heard about this. The advantage now would be the data would be openly available. Any export, but any public entity could look into this data, any person. But at the same time, they would be immutable and also censorship resistant. You have then the blockchain as a second pillar of that, which does the notarization and can also be used for smart contracts to incentivize certain things. And they will basically ensure the attribution, which is something very important for scientists. And it can then, as I said before, trigger processes like the patenting or the licensing of things. All right, so now with this, I hand over to Gotthold again, and he's going a little bit into this idea of the mechanics, and maybe just to highlight this. So we believe that...
2 minutes.
You have 2 minutes. Okay, go ahead.
So until we're done. Okay, so incentives are a pretty important part. He talked now about architecture, but we want to also incentivize people to behave fairly. So what we're going to introduce most likely are 2 tokens, reputation and power. Reputation is creating you power to do stuff, meaning to submit things or, generally act in that environment. At the same time, reputation is enabling you to participate at votes, So there will be a proposal and you say, yeah, that sounds good. Okay, that you can do if you have enough reputation, that you have earned formally in that network due to, reproducible studies that you have uploaded or general well behavior. Now, you can submit, so these are the 2 tokens, basically. Power is scarce, it will be reproduced, and will prevent you from spamming the network, because at some point you won't have enough power anymore. Now, where do you submit all that stuff? You submit it into these contracts. The contracts are, well, not the stuff, not the data. What you submit to is the hash, that identifier for the data. You submit that into one contract, that is that project that you were talking about. Now, what is interesting, out of one project, it might be that there are other projects, growing out. So, you have started, for instance, with a project saying, I want to understand the brain. Well, big project. There will be other coming from there. I want to understand the, eye, and then I want to understand the starburst cells or whatever, and then you will have from this one contract, that one project spreading out more and more projects. You can submit into these projects the hashes of the data or different proposals on which can be voted due to this reputation token. Now, this leads to something, this recursiveness, it's kind of a recursive thing, is if the contract creates another contract or several, something comes into life which we call the tree of knowledge. It would be basically this kind of, it's a simulation kind of thing, how it would look like. You would have a seeding problem, so here would be a seed, at the beginning you want to get something solved, and then you work your way through, actually not you, but the whole scientific community would try to work through to find, for instance, one solution, and at the same time funding lots of other things. The red would say, okay, we have understood the project, it is accepted, we have found the things that we have wanted to find. Red, not yet. So then you would have something in the end like an audit tree, as already Martin said, you know, so that would be, for instance, the solution that you wanted to have in the beginning, this one, that you wanted to have in the beginning, and you can find your way through, you know, you see how it has all been created, who contributed what, and really see all the data also that is, you know, behind the hashes uploaded into this data storage. This would be like, you know, just an example. If you want to, you know, for has happened already, you know, mainly like the DNA, you know, the finding of it, you know, with Mendel basically, who worked on his theories on inheritance with the peas, you know, that story probably, you know, and then from that one you see other basically that are based on that, and others will be split works of that one. So it's all growing basically until you are at that point here right now. Well, probably we're at that point, which is not drawn yet. Okay, that would be the tree of knowledge basically created. So what is it where we want to be in the end, you know, with all this new architecture, with the incentives like this power reputation token, with this tree of knowledge? Well, where we want to be is like having a social network for science. Everybody should be able to contribute to that network, you know, everybody really. And you would be able to submit data, make proposals, you know, accept proposals, and therefore enabling really everybody to participate freely to his desire, his or her desire, and also ability. You know, at the same time, it would be all fair and collaborative, because you would have the tokens controlling the interactions of the different participants. And that's it.
Thank you very much.